Welcome to the Unit 1, Section 6 video on solving inequalities. So we've talked about solving equations, and now we're going to talk about solving inequalities, and it's going to take on the same kind of look, very similar to solving equations. Most of the procedures here are going to be the same. So to solve an inequality, you need to isolate the variable using the properties of inequality and inverse operations. So just like we have properties of equality, we have properties of inequality, where if you add the same thing to both sides, you preserve that inequality. Same if you subtract the same thing from each side, you preserve that inequality. And in both of these definitions, we're using less than, but you can apply this to all inequalities, including greater than or equal to, and less than or equal to. So let's do a couple of examples. For A, we have x plus 9 is less than 15. We are going to solve this by subtracting 9 from each side, and that gives us x is less than 6. And now that we have the solution, we can graph the solution by putting an open dot at 6 and graphing all values that are less than 6. For B, we have d minus 3 is greater than negative 6. To solve this one, we're going to add 3 to each side, and that gives us d is greater than negative 3. So our solution here on a graph is an open dot at negative 3, and we're going to shade to the right. Solving inequalities by multiplying and dividing also going to work in a similar manner. To solve an inequality that contains multiplication or division, undo the operation by dividing or multiplying both sides of the inequality by the same number. The rules below show the properties of inequality for multiplying or dividing by a positive number. Okay, so multiplication property of inequality for positive numbers. You can multiply each side by the same positive number and it preserves the inequality. Same thing for division. You can divide each side by the same value and it preserves the inequality if your number is positive. These properties of inequality are true for not only less than, but also greater than or equal to, and less than or equal to. So we're going to solve each inequality and graph the solutions. So for A, we're going to divide each side by 3, and that gives us x is greater than negative 9. And when graphed, we have an open dot at negative 9, and we're going to shade to the right since it's all values that are greater than negative 9. For B, we're going to multiply by the reciprocal of 2/3, and that's going to give us r is less than 9. This can be graphed by an open dot at 9 and then shading to the left. What happens when you multiply or divide both sides of an inequality by a negative number? Well, let's explore this a little bit. Look at this number line, okay? We're going to use this as kind of a visual aid to see what happens here. So let's talk about two inequalities. We've got 2 is less than 6, and 6 is greater than negative 2. Both of these are true statements. You can use that number line to verify that. Well, let's multiply both sides by negative 1. So that gives us negative 2 is some sort of inequality to negative 6. And we have negative 6 is some sort of inequality to 2. All right, well, what are we going to put inside these boxes? We're going to use the number line to determine the direction of the inequality. Well, we know that negative 2 is greater than negative 6 because it's to the right of negative 6 on the number line. So negative 2 is greater than negative 6. Negative 6 is going to be less than 2. So notice that when we multiply, or in this also will work for division, if we multiply both sides of an inequality by a negative number, you must reverse the inequality symbol because you notice 2 is less than 6. If we divided or multiplied each side by negative 1, it became negative 2 is greater than negative 6. 6 is greater than negative 2, multiply or divide by negative 1 on each side, and we get negative 6 is less than 2. This means there is another set of properties of inequality for multiplying or dividing by a negative number. We have the multiplication of property of inequality for negative numbers, which states that if A is less than B, and we multiply each side by a negative number, then we have to flip our inequality sign to greater than. The division property of inequality states a similar thing. If A is less than B and we divide by a negative, then we have to flip our inequality to greater than. These properties also hold true for the other inequality symbols. So let's do an example of this. We're going to solve each inequality and graph its solutions. So for A, we need to divide each side by negative 8. When we do that, we have to flip our inequality sign. So instead of greater than, we now have less than. And our solution is x is less than negative 9, which is graphed for you here. For B, we have to multiply each side by negative 5. Doing so, we have to flip our inequality sign from less than or equal to greater than or equal to, and that gives us 15 is greater than x, or x is less than 15, less than or equal to 15. Okay, you can flip the whole thing to aid in your graphing of the inequality. Now let's talk about solving two-step inequalities. Inequalities that contain more than one operation require more than one step to solve. Use inverse operations to undo the operations in the inequality one at a time. So let's solve each inequality and graph the solutions. We're going to start A by subtracting 160 from each side. That gives us 4f is less than or equal to 340. And then divide each side by 4, and that gives us f is less than or equal to 85. For B, we're going to start by subtracting 7 from each side. Then we're going to divide each side by negative 2. And that gives us t is greater than or equal to negative 7. Now, notice we did have to flip the inequality when we divided by negative 2. So we went from less than or equal to greater than or equal to. And that is indicated here on the number line where we graph our solution. We can ramp up this process for solving multi-step inequalities, and very much like when we solved multi-step equations, we may need to simplify things by combining like terms or using the distributive property. So in A, we're going to start by combining our like terms. Negative 4 plus negative 8 on the left-hand side is negative 12. And then we're going to add 2 to each side. And that gives us negative 10 is less than negative 5c. Now we've got to divide by negative 5, and in doing so, we have to flip the inequality, and that gives us 2 is greater than c, or you can flip the whole thing and read it as c is less than 2. That aids in our graphing on our number line. For b, we have to distribute the negative 4 to the 3 minus x, so we have negative 12 plus 4x is less than 4 squared. Then we're going to square the 4. That gives us 16, because remember, 4 squared is the same as 4 times 4. Now we'll add 12 to each side. That gives us 4x is less than 28. And then finally, we're going to divide by 4, which gives us x is less than 7. And here it is graphed on the number line for you. Now let's look at solving inequalities with variables on both sides. You can solve inequalities like you solved equations with variables on both sides. We're going to do this by collecting all the variable terms on one side and all the constant terms on the other. And then we're going to solve the equations using the phrase, "don't call me after midnight," remembering the steps for solving inequalities. Distribute, combine like terms, move the variable to one side, add or subtract the constants, and then multiply or divide the coefficient of your variable. So let's take a look at this in examples. So starting off with A, we have to move the 3x over to the left-hand side, or you can move the x to the right-hand side. So let's do it that way. If we subtract x from each side, that gives us 0 is less than 2x plus 8. Then we're going to subtract 8 from each side. That gives us negative 8 is less than 2x. And then finally, dividing by 2 is going to give us negative 4 is less than x, which you can now flip as x is greater than negative 4. And there it is graphed for you. For B, we have 6x minus 1 is less than or equal to 3.5x plus 4. We're going to start by moving the variable, subtract 3.5x from each side, or you can subtract 6x from each side. Either way works. In this way, we subtract 6x from each side. We get negative 1 is less than or equal to negative 2.5x plus 4. Then we're going to subtract 4 from each side. That gives us negative 5 is less than or equal to negative 2.5x. We divide each side by negative 2.5, and in doing so, we flip our sign. And that gives us 2 is greater than or equal to x, which we can flip as x is less than or equal to 2. And there it is, graphed for us. Closed dot at 2, shaded to the left. In example 7, we're going to solve each inequality and graph the solutions. So in A, we're going to need to distribute the 6. That gives us 18 minus 6x is less than 3x. We'll add 6x to each side. That gives us 18 is less than 9x. And then we'll divide each side by 9 to give us 2 is less than x. That can also be written as x is greater than 2 when we flip the entire inequality. And that helps us in graphing it. For B, we have decimals here. I'm going to start with a shortcut, because if you do not like working with decimals, here is a way to get rid of the decimals. Remember, whatever you do to one side, you can do to the other, and your inequality is preserved. So I'm going to multiply each side by 10. That moves your decimal place to the right 1 on all your numbers. So that gives us 16x is less than or equal to negative 2x plus 36, which I think you'll find is much easier to work with. We're going to add 2x to each side. That gives us 18x is less than or equal to 36, and then divide each side by 18, giving us x is less than or equal to 2. And there it is, graphed for us. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.